And what's poppin', slime? Today, we are going to talk about the law of cosines. I've worked very, very hard on this set of notes for you today, and almost none of that time was spent actually working on notes, as you can see. I'm very proud of this set of notes. I've worked incredibly hard. I've made it the best I can possibly make it, because you deserve the absolute best. So, we're going to learn about the law of cosines today. This will be the last law that we need to learn about, and then review and test. So hopefully it's pretty good. All right, so let's go learn about the law of cosines. So here is the actual law of cosines. There are a couple of different versions. Pardon. Oops. Oh well. All right, we'll get to there when we want to. Okay, so here's the law of cosines. What the law of cosines tells us is the length of side C. So we want to know how long is this side. Okay, there are a couple other things it's good for, and we'll see that on the next slide. But it tells us side C. And now you're going to say, what's special about side C? If I have this triangle here, how am I supposed to know to label that side C? What's to keep me from labeling it A, B, C like this? What if I mess it all up? How do I know which one to label? Don't worry about it. We'll get to that on the next slide. Okay. So what it tells us is it'll tell us how to find this side C. You'll know it's side C because on this side of the equation, let's investigate, shall we? Okay. So a squared plus b squared equals c squared? Where have you heard that before? A squared plus b squared equals c squared? Okay. So this chunk right here is basically Pythagorean's theorem. But we have this minus 2ab cosine c. Fun fact, Pythagorean's theorem is for right triangles. And it tells you the side across from the 90. What happens if we make C 90? Cosine of 90 degrees is 0. So 0 times anything, this goes away. So the law of cosines is very close to being the Pythagorean theorem. This is a more general version of it. So it's pretty handy. So let's investigate this. A is this side length. B is this side length. Angle C is the angle made by these two sides. So what the law of cosines does is it says that if I know two sides and the angle in between them, I can use the law of cosines to get the missing side. Okay. So let's go back to that question that I asked that you don't care about from earlier. What if you label this a different way? What if you accidentally label your triangle as A, B, C, like that? If you know B and C, this is angle A, you can swap around the A, B's, and C's just so long as you get everything, the correct geometry of the angle and triangle captured. What I mean by that is A and B are the sides you know. Okay. C is the angle in the middle of A and B, and you have to know that angle also. C is the side you don't know that is straight across from C. So if we knew B and C from here, the law of cosines can be rewritten as A squared equals B squared plus C squared minus 2BC cosine of A. If I permute these, or if I rotate the letters around again, we could get a third version where b squared equals some stuff. The point is, C is the side you're looking for. And then A and B are the sides you know. That's really how you're going to keep these straight. That'll tell you how to label them. I believe on the examples we have today, I have not labeled them A, B, and C yet. So I'll help show you how to label them correctly. Okay. The important thing is the thing you want to find goes all by itself. The stuff you know goes on the other side. Good? All right. So this is the law of cosines. This is how you're going to see it if you look it up, I believe. There are different versions, right? There is the a squared equals b squared plus c squared version I just showed you. Right here. There's also another version with b squared. And then on the next slide, I'm going to show you a version where we've solved for the angle, or we've gotten cosine c by itself. So there's a couple versions, but I believe this is the one you will see if you look it up on like Wikipedia or something. Okay, so there's the law of cosines. You're going to want to, remember this for the rest of your life. But let's go see what it's good for, and now let's do some examples. So what is it good for? Law of cosines does two things very well. It is good at solving for a missing side. And really, you want to use law of sines if possible, because what's simpler, this or this? Right? I would much rather use this law of sines than this big nasty law of cosines if I can. But like we learned yesterday, there is not, the law of sines does not apply to every single problem in existence. It doesn't work on everything. For the stuff it doesn't work on, you have to use this law of cosines. So it's good at finding a missing side if the law of sines won't get us there. Or if you know all three sides, then the law of cosines is really good at finding an angle. So another version of the law of cosines you might want to write down is this one. This is the same as this. It's just that cosine of C has been solved for. So what they did is they added this over, they subtracted the C over there, they divided by the 2AB, and then they got the cosine C by itself. They've done all that algebra for you. It's enough algebra that it's kind of worth writing this down on its own, just so that you have it available to you and you don't have to go through and do the algebra. However, I'm not your mom, and I'm not going to make you write it down. I'm not going to drive to your house, hold a protractor to your head, and say, write it down or else, right? So I highly recommend that you write it down for your own sake. But again, I'm not your mom. All right, so let's go use this wonderful law of cosines on a couple of example problems so that we can see how useful it is. All right. So our first example, we're trying to find the missing angle, and I haven't even told you which angle. So let's just go ahead and pick one. I'm going to use angle C just because the law of cosines that we know, C is the one inside the cosine. So just to be consistent, we'll find angle C. But just so we're clear, you can use it to find angle A or angle B. It really doesn't matter. You just have to rearrange some of the terms and make sure you put everything in the right spot. I may show you how to set them up. So that's not what I wanted. Let's whoops. There we go. Okay. Let's go ahead and lock this stuff down. Here, let's go ahead and lock that so that that doesn't accidentally happen again. All right, so what we want to do is we want to solve for angle C right here. So we're going to set up our law of cosines, and because we are looking for an angle, we're going to use this version right here. So let's grab this thing. Let's just copy it over. Copy. Take it over here. Paste it right there just so we have it. So we are looking for cosine of C. We're looking for angle C. So we want the cosine of C by itself. So we're going to have cosine of C equals a skinnier pen. A squared. So here's A. A is 8. So that's going to be 64 plus B squared. What is 19 squared? I'm not sure that I know that right off the top of my head. It's definitely less than 400, but it's not something that I know right off the top of my head. It's 361 minus C squared. So 14 squared is 196. Okay. All divided by 2 times A times B. Okay. So if you're looking for an angle, really not super complicated. All that's important is that the angle you're looking for, the side straight across from it, should be the one that's negative in the top here. Okay. Once you have this labeled and you got a good idea of what everything is labeled, A, B, C, then you just plug them into this formula like this. Then you take this thing and throw it into your calculator. When we do that, we get, let's go ahead and throw that into our calculator. So we've got 64 plus 361 minus 196 divided by 2 times 8 times 19. And we get cosine of C equals 0.002478. More decimals is always better. And then to get angle C, all we have to do is do an inverse cosine on both sides. So we do inverse cosine, inverse cosine. So we'll do inverse cosine of that number. And we get, oh, hold on. I may have, hold on one moment. Pardon. I seem to have, I hit too many buttons in my calculator. Excuse me. This number is slightly incorrect. Let me fix that. Sorry. Happens to the best of us. When you throw this into your calculator, you actually get 0.753289. Then you do your inverse cosine. And when you do that, your cosines cancel. And you get C equals 41.124 degrees. Okay. So for your law of cosines, you're going to find A, B, and C. A and B should be the sides that make the angle you know, or are looking for rather, that you are looking for. C is the side straight across. Throw A, B, C into this formula. Simplify your fraction, inverse cosine, and you'll have C. Make sure your calculator is in degrees so that C will come out in degrees. Otherwise, you're going to get some nasty decimal that doesn't really make sense. It'll be a little less than half of pi. All right, so that's law of cosines if you're looking for an angle. Let's find our missing side. So here's our missing side. And I haven't labeled A, B, and C on this one. Let's label that first. So here are the two sides that make up the angle that I know. Those two sides have to be A and B. Which one is A and which one is B does not matter. So let's just say this side's A, this side is B. Then the angle in between them is capital C. That makes the side across from that angle that we're looking for baby C. All right. So we've labeled these. We've got our A, B, and C now. Now we're going to just plug this into the law of cosines, which is C squared equals A squared plus B squared minus 2AB cosine of C. So we're going to plug in our two numbers. So we're going to have C squared equals 46 squared plus 60 squared minus 2 times 46 times 60 times the cosine of 45 degrees. And then once you have your sides labeled and your numbers plugged in, you are basically home free. When you do this, you get this thing simplifies to about 1,812.8. And then we don't want C squared, right? We want just what is C. So we take a square root of both sides. The square root cancels the squared, and we get C is approximately equal to 42.58. And because these are in feet, we would want to put feet on here as well. Now, I can kind of hear you guys whispering, but Mr. Barton, I took a square root. Don't I need a plus or minus? The answer to that is no, because we are solving for the length of the side of a triangle. You can't have a negative length of something. So we just throw away the negative answer and keep the positive one. And there you go. That's the law of cosines. I don't feel like you need way more examples, so I don't have any. If you feel like something about this was a little muddy, a little unclear maybe, go ahead, hop in the WebEx. Maybe give your homework a shot anyway. And when you get a 6 out of 10 on it, ask me for some help. If you feel like you're going to get a 6 out of 10 on it, maybe before you submit it, say, hey, Mr. Barton, would you mind just giving my math a once over? Check maybe for mistakes or anything, any clear errors you think I've made. I would love to help you with the law of cosines. Have a great day.